I'd like to call the last speaker of this day, Dr. Moran Cerf. He's an assistant professor at the Kellogg School of Management and Neuroscience at Northwestern University. He has a background in physics and a past hacker, and he's actually combining hacking and neuroscience, which is kind of an interesting combination. Dr. Cerf, please. Sure.
Perfect. Okay. Thank you. The last session of the day. I feel privileged to have some of you still stay with us towards the end. This is my 4th time speaking at this event. And I was trying to reflect on what new things I can tell you about using the brain in security. And I'll tell you a few things about how neuroscience and how my field of research actually informs cybersecurity and tries to use what we know about the brain to challenge our abilities to think and to reflect on security in the years to come. So I've been here for 3 years now, sorry, and I tried to also reflect on what happened to me and to the field since I started speaking here. So 4 years ago, I spoke here first. I had much longer hair, much grayer, much darker hair compared to the graying one that I have right now. I also noticed as I looked at pictures from the past that I always wear the same blue shirt. So I tried to change at least one thing about myself coming this year. When I try to think about what to tell you about the year 2016. But I also try to reflect on the things I've said before. And when I looked at the things I spoke about in the years before, they started with talking about things that seemed like they're going to be in the future, and you just heard that they're actually in our present. And they went deeper and deeper into an understanding of the brain and what it can tell us about neuroscience. So 2012, I spoke about hacking the human body, and now looking at the insulin pumps or defibrillators and pacemakers can actually allow us to do something that changes people's behaviors. This at the time seemed like a futuristic thing, but now with the ability to edit genes in a living human, we can now know that there are ways to change your traits, change your personality after you're born, just by doing things that affect your body. So this is a thing of the present right now. Going into 2013, we spoke about how to use neuroscience to actually extract information from your brain. The idea being that we more and more have an understanding of how brain functions work, which sites control what cognitive aspects, and we can now start looking with very low resolution at sites that have to do with familiarity. We can show you passwords and know if you recognize a letter or a character or a digit in them or not. We can look at parts of the brain that come to life when you look at your password and see if your password has a semantic meaning. As in, is it a word that you recognize or a scrambled set of characters? And you can start knowing something about your choice of passwords just by looking at the brain. And the reality is that the only thing that stops us from being able to read entirely things in the brain is just the resolution of our acquisition devices. The better we become in looking at the individual neurons in your brain and seeing how they work, the more likely we are to understand more and more about your passwords. Now this was 2013. 2014, I almost ran out of topics. And I went into our project done by a colleague of mine at Stanford, Dan Bonnet, who actually looks at ways to place passwords in your brain that you don't know. You can use them when you're confronted with a problem. You can actually express the password when you type it, but you have no idea what password is. It's sitting in your brain, and it relies on the fact that we can train you to do things and stick information in your muscle memory without having you actually know the information. So no matter how much torture I would go and put you through, you wouldn't be able to actually give me the password. Only when I ask you to type it, it will emerge. And even though this is mostly a theoretical idea right now, we actually show in a variety of experiments that people can actually learn after 30 minutes of playing a game something about the code of the game. And then 2 days later, when they're asked to play the same game, we can tell who was the person who was trained before and who wasn't. So now, 2016, I try to see what else I can tell you that's new about the brain. And the reality is that there's now 3 fields where neuroscience is actually making strides and trying to understand how we can use our understanding of the brain to also inform security. And those are the fields where we're trying to understand how we can make people do things, regardless of whether they wanted it or not, how we can make people see different things than what their senses offer, and how we can actually make us think things that weren't there before. Essentially, in the world of hacking, we're trying to see how we can hack our sleep, hack our perception, and hack our cognition. So I'm going to try to give you, in the next 10 minutes, 3 examples for 3 experiments that are being run right now that allow us to imagine a world where those 3 things are going to be something that hackers could use to actually challenge our perceptions. Hacking our sleep. In the last year, I've been involved with a number of studies that try to go into the fortress, the palace of your mind, and actually change how it works. Now, think about your brain as a little fortress that encapsulates all of your information, all of the things you learned, your memories, your feelings, your decision-making processes, your entire character sits out there. Only that, unlike any bank or any financial institute that you really protect well with firewalls and VPNs and application securities, this fortress actually removes all its guards for a third of the time when you're awake. Every day, for about a third of the day, we just go to sleep and essentially have our brain totally go into a safe mode where it doesn't really protect itself anymore. It's as if you have a bank that for 8 months of the year uses the most complex security, but for 4 months just has everything go in plain. This is how our brain works. We have a moment in a day where our brain doesn't really spend time protecting itself. And this is almost a curious question, evolutionary. Why do humans have such a brain? Because if you look at our brothers and sisters, evolutionary tree, we can see that many animals actually solve that problem. So dolphins actually go to sleep only one hemisphere at a time. So they have half their brain awake, even when they're asleep, to protect themselves. Birds can even fly while they're sleeping because part of the brain that has to do with muscle control is still awake, even though they're asleep. But only us humans are turning off for 4 hours or for 8 hours out of a day and are basically, essentially, entirely vulnerable. Now, the reality is that sleep is an even more curious moment because it turns out that when we're letting our guards down, our brain actually keeps working. It just does things that are not entirely under our control. And specifically, what we know right now is that sleep is broken into stages, and that some of those stages, notably one known as the slow wave sleep process, is a moment where your brain actually evaluates the day and decides what to make of it. Imagine it as if there's a database of all your memories, all of your experiences of the day sitting on one side, and overnight, in a specific moment, your brain selects some of those moments that it thinks are important and moves them into long-term memory, into a better and safer storage where it's going to be used in the future to make better decisions. Now, you can't store everything, so your brain overnight chooses some, the more important ones, and moves them. The others it suppresses or entirely erases. And the way the brain chooses that is by a process that is very, very complex and is relying on years of evolution. But what we know right now is that as of the last 2 years, we understand somehow how this process works and when it happens, to the point that we can actually do things to the process that changes how it works. So in rats and mice, there was a famous study where people basically gave them beta blockers, a particular pharmaceutical that stops the process from happening, essentially rendering the memory not active. So overnight, the rat tries to take memories from one side to another, but the drug that you give it stops it from happening, and then it just loses all its memories because nothing actually stores them in the same place. And in humans, we can't do that right now, but we can shape the process. Turns out that in a very, very simple way, using smells and tastes and touch and things that actually penetrate your sleep without waking you up, we can trigger your brain into choosing some memories, but not others that we select from you. So if I give you the right smell, I might change your pointers such that you will choose this memory rather than that memory, and you will store that rather than this. And essentially, I can choose for you which informations are going to be going from the short-term memory into the long-term memory. Now, when you go into this dimension, we can imagine a world of opportunity. We can actually imagine maybe changing your preferences overnight into choosing one versus the other, to the point that when you wake up the morning after, I would ask you, say, to choose a password, to renew your password for a website, and you would randomly and intuitively and by yourself choose a password, only that we learn afterwards that overnight, I selected for you the things that are going to be in your cache memory, and the password that you choose is going to actually be triggered by me overnight, where I nudged your brain into one direction rather than another. And this is not science fiction. We already do something like that in the lab right now. We take people, we have them go to sleep, and overnight we nudge their behavior a little bit, such that when they wake up, we have them make a choice, and we affected their choice. This time we're focusing on health choices, so we make them choose salad rather than a steak, but the idea is the same. I choose for you overnight something that when you wake up in the morning, you think you selected yourself, but actually you were under my spell. So this is how hacking sleep works. What about hacking our perception? So in the same way that I mentioned to you that overnight things move from one place to another and get stored, we can imagine a process that all of you hackers know as race condition, where there's one system here that gets information, another system there that feeds information, and the two of them assume that they speak the same language. As in, when information from database 1 goes to storage 2, you don't authenticate anything anymore. This is how our brain works. Our brain on the inside doesn't really authenticate each process. So this part of the brain thinks that whatever came from this part of the brain is just clearly the same thing that it was determined to be. And if I can come in between and change information inside your head, I can essentially make your brain store information that it thinks comes from itself, but actually came from me. Now this isn't just vague. This picture that I put in the background is a picture of one of the patients that uses a cochlear implant, a device that basically tells its brain what is out there, such that its brain thinks it's hearing. Now, when you think of the brain, you think about the brain as seeing, hearing, smelling, and tasting the world, but the reality is it's not the case. Our brain is sitting in a very, very safe place under a structured bone. It's not seeing anything, it's not hearing anything, it doesn't even have access to the world. All it has is a bunch of liquids that surround it, and a very, very rigid area that makes it not move. The brain doesn't see anything. It sits in a dark, dark place full of water. So all you know about the world comes from plug-and-play devices that feed into your brain, is in your eyes, or your nose, or your ears. Now, there's a contract between your brain and those devices that says that whatever comes from them is real. But this is a contract that is only true because no one challenged that. If you look at the world right now, what you think you see is the entire world, but we know it's not the case, because we know that out of your pockets comes an array of cell reception that speaks to your phones, and even though you all believe that those reception cells are here, none of you sees that. If I released a bat in this room, it would actually see those rays of light, and it would actually fly between those, because its plug-and-play devices are aware of the rays that come out of your pockets. Now, we don't see them because our eyes are unable to see it, but the eyes of the bat are able to see that because it has an echolocating device that is sensitive to those. The thing is, inside the brain of a bat and inside the brain of a human, it's the same brain. Almost the same senses, almost the same ideas function when you look at the brain of a human and a bat at the level of the neuron. So if I could take the bat's eyes and feed those into a human brain, we can actually have our brain get signals that it knows how to process and start seeing more of the world. Now, we know that what we see using our eyes is only 1/1,000,000th of the amount of things out there. And our brain is able to see much more, it's just that our eyes don't have the capacity to do that. And because the brain can do those things, we can actually feed a device like the cochlear implant into our brain, have this device learn how to parse molecular changes in the air, and have the brain learn over time how to hear, even if it never heard anything before. But the same idea works for all animals. You can take any of the animals that have no eyes, but have devices that allow them to, say, touch the world and feel what's out there just using those fingers. This is the star nose device that has 32 fingers that allow it to see the world just by touch, or the male moth that actually has this unique nose that can identify a female moth even if it's within 10 to the 17 different molecules of air are under. It's like an undergrad in Tel Aviv University who can smell any female undergrad in the entire state of Israel, which I think exists right now. So the idea is that we can actually tell our brain that what it gets isn't reality, and feed more information into it and allow it to parse more information. But if we go into this domain, we can actually imagine someone using it against us. I can actually feed into your brain more information, making you not see things that are out there or see things that are there. Now, again, this is not science fiction. We now know that we can actually take subjects in experiments and actually put goggles on their eyes that take the rays of light that their eyes don't recognize, but have sensors that do recognize, feed those into their brain, and have them wear goggles that basically see more things of the world, say the rays of cell phone receptions that are out there, and translate them into something that the eyes can see. After a week of wearing those goggles, the brains of those people actually start seeing the rays of light, and they can actually start walking in the room, avoiding cell reception sites. Now, this means that the brain, within 1 week, can actually learn to see more things if you just give it a new plug-and-play device. And if you go into this domain, we can actually understand how the brain, which has one side that just sees, another side that senses, can actually allow itself and ready itself for a person to come in between and change our perception, as in hack what we think is reality. And the third and last experiment is one where we try to hack our cognition. Now, we think that cognition is what makes us human, but we know from games like Jeopardy done 5 years ago that actually the field of AI and machine learning allows us to really mimic the way the brain thinks and create machines that essentially behave like us. Machine learning algorithms actually don't know the answer to problem. They just get a lot of examples, and they somehow find the rules that govern those by themselves, somehow mimicking the way we think. We don't really teach people things by telling them this is the rule of how language works. We just show you a lot of words, play to you a lot of sounds, and have you somehow, as a child, learn language, or learn how to move, or learn how the world works. And what it means is that more and more algorithms are actually controlling the world around us and making choices for us. Notably, one of the biggest hacks in the world, the biggest theft of money to date, happened May 6, 2010, 6 years ago, and it was a theft at the amount of $1.2 trillion, and it was done by an algorithm. Known as the flash crash of 245, the New York Stock Exchange at 245 May 6 suddenly experiences a huge theft of money. Stocks at the amount of $1.2 trillion, which is almost the US debt to China, disappear randomly and fortunately come back after 20 minutes. Now, to this date, no one knows what faulty algorithm led to this loss of money. Fortunately, the same algorithm decided to bring the money back. But if it weren't doing that, we would still be now chasing the largest amount of money stolen without having a person to fault for that, because it would happen by a computer. In the same way, algorithms are now governing our preferences. The most expensive book on Amazon to date is this book called The Making of a Fly. It's a textbook in entomology that has to do with insects and their life. It has about 100 copies sold a year, even though it's out of print, mostly used books. And its price on Amazon right now is $1.7 million. Even though it doesn't exist, no one prints it anymore because it's sold in the used book market. Now, if you bought this book right now for $1.7 billion, you actually would make a bargain, because when it was up for sale and people started noticing that this is the price, it went up to $23 million plus $3.99 shipping and handling, because this book is sold by an algorithm that decides by itself what is the interest right now and highs or lows the prices based on what people think is important. And what's behind that is that we now outsourced choices of sales to algorithms that try to think like we think, and they try to make profit like we would, only that they have no sense of insights on about like what makes sense, to the point that they make such mistakes. And more we have algorithms deciding for us what we would like if we bought book number 1, which other books would be relevant. We have TV shows that use Netflix algorithms to decide how to cast characters in the show based on your preferences. And we even have algorithms that are smart enough to know what is embarrassment, as in they offer us movies that we would enjoy watching, but would be embarrassed having our friends know that we enjoy watching. Those are algorithms that know something about us that is very human, and we can't articulate perfectly, but they can. The reality is that those algorithms even have a sense of what clean is. They have different ways to clean our room, thinking that they know something about what we prefer. And ultimately, as we become dumber, they become smarter. In 2016, more people are going to die from extreme selfies than people are going to die from shark attacks and crocodile attacks. And we allocated more and more of our thinking to machines that do it for us. And where it becomes interesting for me is not in the place where we actually allocate our cognition to computers, but in the idea that we still think that there's something that saves us. And I'm going to end by telling you that I don't think this is the case. In the famous Jeopardy game played by humans against computers, in 2011, the computer won. This is not surprising to you, but what is surprising is that there's one moment that was entirely overlooked that I find as the most telling moment I want to end with. This is a moment where the computer actually was able, for the first time, to top the human. Humans were leading for a while. The computer actually takes question and now takes the lead.
Correct. Legalese for 800.
And what you see is that the human got really upset because it tried to press the button fast enough, but it was just too slow for that. So it missed. So it tries to be faster in the future.
Yes.
Lower the sound.
This clause in a union contract
Then he tries to take the
says
second
that
question and be
wages
fast,
will
but it's
rise
still
or fall
too slow.
depending on a standard such as cost of living. Watson.
What is
And Watson,
escalator?
the machine,
Yes.
gets better and better
For
and starts
400.
taking a lead
This
over the
plain
human.
blue
And the
sheer
human
fabric
gets to a
made
moment
with
that I find the most
yarn
interesting moment.
is also
And this is
used
the
to
moment.
describe a pie or cake.
A question emerges,
Ken.
and the human presses the
What
button,
is,
takes a pause, and then
Chiffon,
answers
like
it.
you are.
what
He
can
doesn't know the answer. He just knows he knows it. So he presses fast the answer and he says, I'm gonna hope that my brain is gonna come up with something and give it to me. And we as humans rely on that as the last thing that we say is gonna make us win against computers. We think, okay, yes, computers are faster, they're better in having all information, but we have this unique thing called insight that allows us to press the button before we know the answer and wait for our brain to come up with that. The thing is that I spent the last winter working in CBS trying to help TV writers come up with a TV series about hackers and the brain. And at some point, I offered them an interesting idea. I told them, what if we have an episode where the machines win, where humans lose? And they were laughing and said, no, no one was going to want to watch a TV show like that. And the reality is that right now in Hollywood, all of our movies are made in a specific protocol where first there's a battle between the humans and the machines. We build them and they become smarter and tougher than us and they start beating us in things. But somehow, even though the battle seems like we're going to lose it, it comes to moment 75 in the movie, towards the end of the movie. Somehow, through the virtue of insight or love or intuition, humans take over and they win. And what I'm seeing as a scary thing is the fact that Hollywood makes those movies the way they make them only for one reason. Because right now, the movies are made for humans. Once computers are going to start making their own movies, we're going to have the same beginning. We're going to build a computer that's going to be as good as us and actually starts beating us. But come minute 75, there's going to be a battle between us and them. And because of the virtue of insight, love, emotion, intuition, they're going to destroy us. Because that's the one thing that makes us human that actually helped Kane Jennings, but still didn't let him win. So where I want to end is by saying that I see computers and machines learning how we think as something that helps us a lot and becomes useful for us, but also as one of the biggest threats right now because we know only how it begins, but like many wars, we have no idea how it ends. Thank you. Salman. Guys,